Okay, so just now you learned about boiling. Okay, so actually evaporation is a very similar process to boiling. Okay, so let's now explore the differences between boiling and evaporation. So evaporation is a process where you actually take note that liquids can also turn into gases without boiling. That means they didn't hit their boiling point. Okay, in fact, evaporation occurs below the boiling point of the liquid. And it actually takes place at the surface. It doesn't take place throughout the entire liquid. And of course, it is very, very slow. One very good example is like drying of clothes. Okay, your mother always dry clothes. The clothes started to be very, very wet at first, but the water on the clothes will not heat up. Okay, it didn't hit boiling point at 100 degrees Celsius to escape into a gas. What happens is evaporation has taken place. So evaporation allows the liquid to change into a gas without going through the boiling point. Okay, so this actually is possible because some particles have enough energy to escape, mainly because they are at the surface of the liquid. So you can see these three particles, especially these three particles. This is the surface. Okay, these three particles, because they are very, very close to the surface, they have enough energy to escape. You can see how happy they are because once they change into the gas particles, they have a lot more energy. They are more energetic. They are free to roam around. Okay, so some special liquids that evaporate very quickly at room temperature are known as volatile liquids. So one example is like perfume, something very, very common to you. So when you open up your perfume cap, okay, besides being able to smell the perfume, after a while, if you just leave it there for a while, you realize your volume of perfume drop. Okay, why does the volume of perfume drop? Mainly because it actually hit his boiling point. So after hitting its boiling point, it started to change into a gas. So your perfume start to escape, changing into gas particles. Okay, so these are called volatile liquids. So this table shows you the difference between boiling and evaporation very clearly. There are three main differences on basically where they occur. Okay, whether is it throughout the liquid or at the surface. Okay, how it occur. Is it very fast or is it very slow? Or whether is it at its boiling point or below boiling point. So do take note of this. Now let's move on to condensation. So there are three more processes that we didn't cover. Okay, so we are just going to cover very, very quickly because they're actually quite similar to the heating curve, maybe just the direct opposite. So condensation is actually opposite of boiling. Okay, so basically it is actually when a gas turns into a liquid state. Okay, so it starts to cool down, it cools down sufficiently, then it turns into a liquid state. So this process is called condensation. Okay, so you can see this explanation very, very similar to just now that heating curve, but instead of gaining energy like what heating takes place, for condensation, particles lose energy. After losing energy, they start to move very slowly. So it's very similar to you after finishing maybe a very, very tiring PE lesson. So you started losing all the energy already, and because of that, you are very, very tired, so you start to move slower. So very, very similar to particles in this aspect. Eventually, they become slow enough for it to actually settle down to form a liquid. Okay, so next, very quickly, let's just move on to freezing. So freezing is similar to condensation, just that the change of state is slightly different. It's actually when a liquid change into a solid. Okay, you'll notice this new word here called freezing point. Okay, freezing point is actually the same as melting point. Okay, they actually mean the same point. It just depends on whether we are talking about melting or freezing during the process itself, but the value is actually the same. Okay, so that's freezing. The explanation you can see quite similar to condensation. Same thing, they move, they lose energy, they move very slowly. After a while, they no longer have enough energy to move freely. That's where they start to settle down into fixed position. From this paragraph, you are able to tell that initially they are able to move freely, which is actually your liquid state, and settling into fixed position, that is your solid state. Okay, so that's freezing. And how does the graph looks like? It's actually directly opposite of your heating curve. So instead of going upwards, now it goes downwards. Okay, there's still a horizontal line because during this horizontal line, this is where freezing takes place. Okay, where freezing takes place. So what actually happened during this horizontal line? Heat energy. Okay, so let me just change the color so you can see clearly. Heat energy is released as particles are attracted to each other. Okay, so heat energy is released because of that. Then you will also see the states. This is liquid, this is solid plus liquid, and this is solid. So usually at the horizontal line, you will see a mixture of states. And this particular point, we'll know it as the freezing point. Okay, so this is how the cooling graph looks like. Okay, the name for this is a cooling curve. Okay, direct opposite of a heating curve. Okay, the last process that we really want to learn is something not very familiar to you, is sublimation. So we have learned these three processes, but sublimation is actually a direct process from solid to gas. So basically it's like a through train, it skips the liquid state. Okay, so it changes into gas without melting. So there are two examples in our syllabus, iodine and dry ice. Okay, you can also add on one more example that is quite commonly tested, which is your ammonium compounds. Okay, so take note of these three examples. Okay, so these are the ones that actually undergo sublimation. Okay, so there's a video here, two videos in fact, for you to watch. So I leave it to you. You can click on the link to watch. Okay, so as you watch, do observe if there's any liquid involved in the process. Okay, that's where you are able to see what does sublimation really means. Okay, and of course, there's one mind map to show the relationship between all three states. Okay, and for that, I will stop here.